Hello, hello. So today we are going to be here together, hopefully for 1 hour. Before I start, I need to build some trust with the room here, since we are going to be together for a long time. So I'm going to ask you a few set of questions, and you just have to raise your hand to answer. So first of all, how many people here are alone, coming here alone? Like no friends, okay? Okay, quite a few people without friends, okay. How many people are here with coworkers? Wow, okay. And how many people here are with their manager? Okay, wait, phrase again? Okay, so I'm just trying to find out who is lying here. And how many here are managers that are here with their employees? Okay, we have one boss. Yeah, okay. So I'm asking all of this because of this quiz. Who has committed a Git crime they wish they could hide? Okay. Okay, I will show you a few lists, and if you have committed that crime, raise your hand. But I kept in mind who has a manager here, so I'm watching you guys. First of all, who force pushed to main? Lots of criminals here. B, who lost an entire day of work? Yeah, I know that feeling. Who created a merge hell? Wow, everyone, let's go. Yeah, me too. And D, committed secret to repo. It's weird, but all the people that raised their hand to say their managers were around didn't raise stories. Anyway, why I'm doing all of this? I'm going to confess first, because we are building trust here. It's a safe place. I have, of course, all of the above. I have a story time for you guys. I once created a merge hell. It was on my first dev job. I just started out and I was on a project that was a legacy project. My first task was to do a migration of the front end. Nothing really crazy or fancy. And I gave my estimation, it's going to take, I think, 1 month and a half. Yeah, easy peasy. Yeah, it wasn't easy peasy. And I was working with a coworker who was also a junior, and he had to do a feature. And also said, it's going to take me 1 month and a half, easy peasy. But we both ran into problems. And from 1 month and a half, it took us 3 months to do everything. Then we had a huge pressure because we took twice the time that we said we would take. So we needed to finish everything, merge, and push to production. That's what we did. We merged, but of course we have been working separately for 3 months. So when we merged, created a hell mess. And we had to figure out how in 1 day we can solve that problem. But it was such a mess that we didn't think that in 1 day it would be possible. And that's when we had to confess. Back then, I thought to myself, I wish I had the tools. I wish I had all the knowledge in Git so that I could get away with this. I didn't want to confess. I didn't, but I had no choice because I didn't know how to fix that before the manager can find out. And that's why I'm here, I thought to myself, it would be great to have like 1 courses where you can find out how to get away with Git problems. That's why I'm here. But before we start with all the techniques you can use to get away with the messes you create using Git, we're going first to look at what's Git. What's Git? Of course, if you look on the internet, what's Git, you will get this answer. Sorry. Git is a version control system. Okay. I will be honest with you, when I saw that, I was like, what? I understand every single word separately, but together as a sentence doesn't make any sense. What does it mean? Basically, it means that Git tracks files, changes, and version across a project's lifetime. If we look at it under the hood, it means that Git does not edit history. It only preserves the evidence. Now, there is a second thing you need to understand for Git, is that Git solves this mystery with a content-addressed object database. We are going back to that later. It's the two things you need to understand about Git, and everything will make sense. So first, a content-addressed object database. And second, a system of pointers that links everything together. Okay, those are words that you understand separately, but it's in a sentence, it might not make sense for everyone. What does it mean? It means that if you look at normal databases, you have an object with a key-value pair. You have user and name, that's my name. Here, this is normal, this is a relational database. In a relational database, the key is independent from the content. You can edit the value, and if you edit the value, it's not going to edit the key. Nothing crazy. Now, it's not working like this in Git. In Git, it's a content address database, which means that you have a key that is an hash, and the value is the content of the hash. Basically, you have a list of characteristics for the object, and then you compress it, and you put it as a key. So it's the same thing, but one is smaller, and one is larger with all the information. And why this is important? Because the hash is unique, and it's immutable. You cannot change it, which means that every object in Git are unique and cannot be changed. This is absolutely important for the rest of this session, because you will see why you run into so many problems. So how does it look like? Because I understand what I'm saying, but when I first read more about Git, I didn't understand. I mean, I was like, it makes sense, but in my head, I still felt like, I'm not so sure. So what do I do when I'm not sure to understand? I look into it. I try to see how it looks like, to demystify it. Once you remove the mystery of anything, it's become transparent and clear. You're no longer afraid of it, you get it. So how does it look like? So here you have a snapshot of a project, inside of a project, and you have all the folders. And what is interesting here is that you have the first folder that is called .git. So this is where all our Git objects and pointers are living. Everything that you do under Git are in that folder. You can open tomorrow or even next hour your repo, and you look at the .git folder, and you can look inside. So what happened when we look inside? You find this. You have several folders, some files. I'm not going to go over each one of them. I'm just going to go over the ones that are important for this session. So I'm going to go over the object and ref. This is the folder you need to understand. So first, if you look at the object folder, inside, you will find all of this. What is it? It's basically all your commits. If you look inside, you will see this, okay? And if I click on it, of course I cannot click on it, but if I use a terminal to find out what is inside this, you see this. So this is what is inside the commit. So you had the title, and inside it is just some text. Who created it, when, and of course an awful message to explain the commit. That's it. That's it. And all of this is unique and cannot be changed. That's all. That's what the commits are. And now, if you look at over here, head master. This is important because we are just going to look at this. We're going back to the folder of .git. And if we look at ref means references. And inside we find the pointers. Don't worry, I'm going back to it. So inside the pointers, you have inside ref you have heads and tags. We're just going to focus on heads. In heads, we have master. And basically here we have the branches that we create. And here there is only one branch, master. And if we look at master inside, we just find this, which is an hash. So what all of this mean? It means basically that if you look at the ref is for the references. You have all the branches that you name. And the names are readable by humans. It could be master, it could be dev, anything, fix this, you know. And inside, you will only find a hash. And the hash is actually the name of the commit it is pointing to. And that commit is the last commit that has been updated on that branch. So, again, yeah, this. Let's do something much more clear. Here, you have boxes. The boxes are the objects. That's all the commits. Basically, this is all the commits. And on it, you have the tags. And that's the name. And inside the box, you have what is inside the commit. These commits cannot be changed. And most often, they cannot be deleted. You can only add more commits. And they are all unique. Here, it's the branches. It's like a post-it. It points towards this. For example, you can find that information over there. That's it. And you can change it. You can move it around. But if we go back to our theme, that is how to get away with murder. And this is really when I really got it. You know, when you are you are making a conspiracy theory. I see a few people say, yeah, I do that all the time. I know, me too. So basically, you put all the information, all the snapshots, all the information on the case you are working on. And these snapshots are basically the commits. You cannot change it. It's unique. And it's there. And the branches are pointers. So they are the small links that you put together to have the complete picture of what happened. Let's say it's a murder. OK, I'm going to put all the key information on what happened that night. And I'm going to link them together. And you link them together with the branches. That's it. And if you want to change something, you cannot delete it. You have to add a new thing, move things around. You cannot, change the information. You can only create new things. If you look at it from a conspiracy theory board, this is Git. This is it. So what's Git? It's a content address object database and a system on pointer, meaning that every version of the project is stored in an immutable snapshot labeled by its content. Basically, everything that I just said. Pointers connect this snapshot, forming a trail that you can follow to reconstruct exactly what happened. And finally, Git is a murder mystery. Nothing is altered, everything is archived, and the truth is in the timeline. That's it. Now, we more or less get what is Git. Now you are here, you're asking me, I want to know how I can get away with it. I don't want to be fired, I made a mess. Teach me your ways. I will teach you my ways. So first of all, before I give you all the tricks, the first thing you need to do always is to get a perfect alibi. What is a perfect alibi? Start with a branch start strategy. Basically, when you make changes, you need to have your own branch. If you do it on master, it's going to create problems. Basically, if you create problems, but you do it on your own, in your own little corner, you can hide it later. There is no proof that you did that. It's between you and you. So future branches keep your work isolated, And you can keep the main branch clean and safe. The one thing that is important here is that there are actually conventions to name branches. Of course, you can name it however you want. But if you follow the official convention, it's going to be more clean and clear and easy to follow. So the convention is basically that you have feature slash, and then you have what the feature is about, or fix. For example, fix slash logging bug. Of course, it's a fix on the logging bug. Makes sense. And of course, once you merge, you need to delete the branch. Please do that, because I have coworkers that have to chase down for a month to delete their branches. They say, oh, you could do it for me. Yeah, but you could also do it. Anyway, sorry for the rant. But I see a few people laughing. I know, that's painful. So basically, your branch is your alibi. Under the hood, what happened with branches? Like we said, branches are pointers. So when you do it when you create your own branches, you create your own pointer so that you can point at the commits that you have made. That's it. You just isolate things and you can move things around easier for your own timeline. That's all. And this is how it looks like for, of course, creating a branch, nothing new. The other thing you could do is to commit often and early, so your story stays tight. What's great, what I often do at work is small atomic commits. Basically, as soon as you do a little change, of course, by little change, I mean a small fix, I don't know, fix that button, fix that thing. You have to commit so that when later there are problems, you can easily follow the trail of the story because you have sliced down everything. So if it's on a small component, you can squash that down. Easier than if you commit everything at once. It will be much more harder to find out what the bug is than if you slice down everything. And of course, each commit should be a logical unit. And it helps not leaving a mess. Because you have cut everything thinly, you can track that down more easily. And of course, like I said, easy rollback. So under the hood, like I said, each commit is a snapshot. So that is linked to the previous one. And like conspiracy theory board. If you have a doubt, think to yourself, conspiracy theory board, snapshot, link. And of course, you have to keep your story consistent. Again, for the commit, a good commit tells a story. It's honestly so much easier whenever you have a problem or you're trying to find something, if you have a Korean story with the commit. If you can read that down and you know where it's going, then if you get fix 1, fix 2, or fix something, it doesn't mean anything. It's easier and you don't have to look at the code to find out exactly what happened, what did you do, or what the other person did. So this is how you can do a good commit. You put format, and then type, and then description. That's the conventional way of doing that. But you can do it your way, or you can do it the official way, as you want. And that's when you can really give context to yourself, to defend yourself, or to find out who is the real murderer here. So yeah, like I said, commit messages are stored inside the commit forever. Like I showed you earlier, you have the hash and then the content of the hash, and that's immutable. It doesn't change. It's always the same. It's unique. You cannot move it. Like I said, conspiracy theory board. Snapshot, commit, branches, link everything together. If you have just this image in mind, Git makes sense. You just move things around, but you cannot change the snapshot there forever. You can only change the links, like in a real conspiracy board, or add more. Here you have the crime scene, if you do it wrongly, and the clean scene, if you do it well. Don't worry, at the end I will give you the link for the slides so you can have it all together. Now, Git history. This is clear. We know what happened, but here it's not clear at all. Now, covering your tracks. We are here, we messed up, we don't want the boss to find out. How do we cover the tracks? There are many tools. You can use squash commit. Are you guys familiar with squash commit? Have you used it at work? Really? You did? Okay, good, good. Me too. Basically, it's when you have multiple commits that become one. Of course, earlier I said you should slice things down, make small atomic commits. But if it's, how to say, if it's better to have one big commit for your story, for everything together, to put everything together, that's when squash comes out. Usually it's when you did commits that are a bit, maybe the title makes no sense, or or you've been fixing one thing and then fixing again. Basically, when I did it at my work is when I fixed something and then there was still a problem on that fix. So I kept fixing it. So you had fix 1, fix 2, fix 3 of the same thing. That's one of the examples where squashing it makes sense because the story becomes more clearer than having 1,006 on the same thing. One squash, one commit, it's clearer. And the story becomes simpler. So it looks like this. Basically, you just, you can squash that down. Use git squash. And basically, under the hood, when you do a git squash, so you don't actually squash all the commits. They still exist. Again, snapshot, conspiracy board, you cannot delete it. It's forever, it's unique. You just create a new one where you put all the information together. And you move the pointer on the conspiracy board. That's it. The other commits, they are still somewhere. But now we have one commit that is going to sum up everything. It's a summary, basically. And then you move the link so that you can change the history so that the timeline becomes much more clearer. That's it. Nothing crazy. You can also use amending commits. Are you familiar with this? Have you guys used amending commits? Yeah, a few? Yeah, me too, because sometimes I make typo or something, or I click on, I write too fast, and then, I want to change it. Basically, amending commits doesn't really change the commit. It just fixes the last commit's message. So the change are not on the code itself. They're not on the commit, on the content of the commit. They're just on the name. Remember, I'll show you what was a commit. You have the commit message. You just change that one. Of course, if you change it, you create a new commit. You cannot change the previous commit. You just create a new commit that is going to take all the information of the previous one, and you just change one thing, the commit message. That's it. Basically, again, conspiracy board. You take the snapshot, it's the same snapshot, but you put a different name on it. Instead of putting criminal, you put, oh, actually, that's the victim. But that's the same snapshot. And it's easy for making quick correction. Of course, you have to do it before you push it. That's the one thing you have to remember. It's on unpushed commits. That's how it looks like. Commits.end amend. And yeah, like I said, under the hood, Git creates a new commit, replace the previous one with a new hash. And we have finally the final tool in covering the tracks series. It's called Git Interactive Rebase. Do you know this name? Yeah? Have you used it? Really? Why?
Cleaning up the things before I post it, usually head tilde to look at the last few commits and then just either swap them or reorder them.
Yeah, that's basically it. Like everything I showed you earlier, squashing, amending, I didn't show cherry pick, but there are so many different type of Git command that exist. Git interactive rebase have all of these commands, and you just pick. Basically, it's easier. You don't have to do it manually. You just pick and choose. So I'm just gonna show you. So basically, it could look like this, and you decide what you want to do. If you want to pick, if you want to squash, reword. So I'm just going to show you a little diagram so it's more clear. Let's say we have a branch. So we have commit E, commit D, commit C, commit B. Okay, great. Now we use Git interactive rebase. What happens? So here, let's say we want to reword. So reword, basically, it's when you do a Git amend. You can also squash. So Git amend, again, you just change the name of the commit. That's it. You keep everything else intact. And here you can squash. So C and D put together, squash, and then you can edit. And that's when you changes the actual commit, what is inside the commit, the code. And you have this. And basically, you do everything I showed you earlier, but instead of doing it manually, having to write down git, commit, amend, git, blah, 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 you just do git interactive rebase. And like the guy said, you just click, and that's easier. But it's a powerful tool, and that's just another way to do your changes. You can do it manually. You can do it with git interactive rebase. It's the tool that you have in your toolbox. So yeah, under the hood, Git interactive rebase just changes the history. So you keep the previous commits. They don't disappear yet. You just create new ones, and you change the trails. Again, conspiracy theory board. You create new snapshots, and then you just change the trail together to create a new timeline, a new story. That's it. That's all it is. And it's the same for a normal rebase, of course. And we also have this tool, which is called, revert versus reset. I think everyone should be familiar with this. Yeah. So, listen, when you have made a mess, I actually have used that one a few times because I needed to go back in time. That's the point, you commit a mess and you want to go back in time to the time where it was clean and perfect. You can use these two tools, but there is a big but. Reset and revert. Reset is going back in time, and literally you just go back in time. And this is a problem if you are on the shared branches, because the story will be altered. The pointers. I will go back to it later to show you how it goes. Revert is better for shared history. How it looks like under the hood. So basically, revert. You have commit 1, commit 2, and then you have this commit. Oh, I made a mess. What do I do? If you do revert, what you do is you create a new commit that is basically the one before you made a mess, the one you wanted to go back to. It's a new commit. You don't rewrite history. You just put the past in the future. Does it make sense? And that's better for shared branches because the link stays consistent. You don't change anything. Reset is better if you are working on your own. If that's your local history, you can do, well, I think the big lesson here, if you are local, you can do whatever you want. That's on you. So you can do reset if you are in the local branch. So how does it look like? So basically, you go back. So you go back in time. So yeah, reset, you delete the commit. Delete. Revert, you create an anti-commit, a new commit that is going to undo the previous one. But the previous one is still there. That's why you have to do it. There is this separation between local and shared history. Now, that's how it looks like. Basically, you do reset when you want to destroy the evidence, and you do revert when you want to confess. Yeah, I mean, I put bad criminal, professional approach, but if you are on your own local branch, you can do whatever you want. If it's a mess, it's your mess, and you're the only one that have to deal with it. And we have this case that we talked about earlier. When the crime scene explodes, you have all this evidence, all these trails, and one day, poof, they're gone. Let's say you make a conspiracy theory board. You are deep inside it. You are about to find out the truth of this world. You wake up and it's gone. What happened? How do we find all these snapshots and links back? Because you cannot remember everything, all the history. We have a tool in Git for that. Git-reflog. Have you used Git-reflog earlier? Wow, I feel like there are like 3 guys that keep. Okay, disclaimer, I did not use reflog. I mean, I only used once when I lost something. And that's basically the point of Git-reflog. You cannot lose a commit. You cannot, in the sense that the commits are never deleted immediately. It takes 30 to 90 days to be deleted. So if tomorrow you lose something, it's still there. It's just that it's somewhere in the universe, and you have to find it. You find it with Git-reflog. Of course, if it's been 3 months, then no, you're cooked. That's it. That's it for you. But if within 3 months, you still have time to find it back, and you use Git-reflog, you can recover the deleted commit, and you can find out what happened. So Git-reflog look like this. You have a list of commits, and you can just pick and find the one you were looking for. And again, we are going back to my history on Git conflict, Git merge conflict. Basically, I told you earlier when I shared you the story of my merge hell horror story. Back then, I wished I knew how to solve that. I thought, maybe there is that one Git command nobody uses except for this specific case. Will it save me? Well, now, years later, no. That's one of the few cases where there is no special Git command to save you. If you are in the merge hell, that's it. You're cooked. So, why? Why is it like this? Because Git merge hell is basically when you have delayed decision. You had to make a decision earlier, you didn't, and now you have to do it because Git cannot do it for you. That's when Git say, look, I'm not helping you here, it's on you, you have to figure it out. So Git cannot auto-merge changes, and basically Git merge hell happen when you have multiple story, one timeline, and you need to pick things together because 2 things cannot happen at the same time. You have to pick and choose which one is right. It looks like this. And I show you the story of my merge hell, and basically we had to look at every single conflict, one after the other, and make decision. Do we keep this one? Do we keep that one? And it took us actually 2 days, which is, I think, fine, because we had to test if everything was right. And I realized later when I talked to other people about their merge hell story that it was actually a successful story for me because I know a worse story. I have a friend who had a merge hell, and basically they were working 10 had 10 people in one project, and they were working for 3 months separately. One day they had to merge everything, and it was such a mess that they had to start over. They couldn't find a way out because they had, I think, 1,000 conflicts. It's just, yeah, they had to confess to the boss and start over. So, when you have a merge hell, basically, there is no way out. You have to figure it out. Or you have to merge before. You have to merge more often. That's it. So again, that's how it happens. And, I think I show you all these examples, but I think merge hell, more than anything else, is not really an issue of Git or code or anything. It's a communication issue. You need to communicate. That's the biggest problem here, where the human is really at fault. You have to communicate. You have to coordinate. Git cannot help you. No one can help you but yourself. And finally, the famous force push. I never did that. I said it on camera, I never did that. You guys did, I didn't. Yes. You're a bad person. I'm not joking, you're a bad person. Anyway, why are you a bad person? Force push is the nuclear button. Why force push is bad? Force push is bad only when you are in a shared history, when you work with other people. If you're by yourself, you do whatever you want. You do your little side project, you mess around, you create bugs, and everything doesn't work, and your secrets are in the open. That's on you, that's your project, But if you work with other people, especially if that's your job, don't do this, because basically what Git force push do is that it's going to overwrite remote branches pointer. What does it mean? Basically, when you do, because when you do Git force push, is when you try to do Git push and it didn't work, right? I mean, that's always like this. You try, it doesn't work. Okay, you are playing with me, Git. I'm going to use Git force push, and I'm going to push it anyway. But if Git say no, it means that there is a problem here. It's not saying no for the sake of saying no. It's saying no because if you push it, it's going to create problems on the shared history. Basically, when you push it, you're going to erase the work of your coworker. Yeah. So, and of course, you don't really erase it. Like I said, the commits, they live for 1 month to 3 months. They're somewhere. But they're in the universe. Try to find something in the universe. It takes ages. So it's just create problem. Don't do this. Unless you know what you're doing, or you're on your own and you're messing around. That's fine. So, like I said, don't do it. You are a bad person if you do it. I'm sorry. And if you actually want to do it with force release and try to communicate. I say this because, of course, it didn't happen to me, and I will show you why later. But I have friends who were on the receiving end of Git force push. They lost all their work. And when they asked the coworker that used Git force push, why did you do that? Oh, because Git didn't let me push. Okay, but I lost my work. Oh, that's too bad. No, let's not do this, okay? Let's not do this. Again, the etiquette. How to use Git force push in an ethical manner on a shared history. And then, like I said earlier, I did not do Git force push. And I will show you why and what you can implement today or tomorrow at your work to stop the bad people at your workplace, or stop being the bad person. So of course, first you have the pull request review. So essentially, it's basically before you can push anything, you get another eyes on what you just did. And this way, you can catch mistakes and you can learn together. Do you have peer review at your work? I think most workplaces have them, but if you don't, it's a good tool to have, really. And you can build a collective code ownership. That's great. And basically, under the hood, when you do a pull request review, Git is going to compare the commit graphics, and it's not going to modify any objects. And basically you stop Git from doing anything. And once everything is clear, you can move the pointers, you can move the timeline, and you can merge. And again, protected branches. So this is the one thing that stopped me from being a bad person. I know I said you're a bad person, but I did Git force push on my own. Okay, not on a shared history, but on my own. And why I didn't do that on the shared history, it's because at my workplace, we have protected branches. We cannot Git force push. I tried, it didn't work out. And this is the one thing you can implement if you don't have that. I think most people must have that. I hope so. Basically, it's going to, for status text, restrict rook and push. You cannot do any force push, and you can have peer review before merge. Basically, it's just safety net. Stop everything, every crime before it happened. And of course, like I said earlier, this is the conventional commit, so that you have everything together. And yeah, getting away clean. So this is basically a redo of everything I said, everything you need to learn here. Like I said, Git is not complicated. When you think about it as a big conspiracy theory board with snapshots and links together, and you just move things around, you create new commits, that's it. And every time there is a problem, it's either because you didn't link well, or you're not pointing at the right commits, or you messed up with the timeline. But once you have this image in mind, that Git is just a giant conspiracy theory board, everything makes sense, at least to me. Once I saw that way, it made sense to me. And this is what you can take from this session, basically. But I hope for everyone, there is not a lot of things new, but that's the one thing you need to keep in mind, because of course I showed you all the different Git commands, but I don't know them by heart. I don't. And I think most people don't. That's why we have internet. But the one thing you need to learn is not all the commands. It's what happened under the hood when you do them. Once you understand how it moves, how it works, then commands are just names. And yeah, like, again, the sheets. And that's it. The best Git crime are the ones that no one discovers. And this is me. That's my quote. Thank you.